Hello and welcome to this, my NAPLAN video for 2016 non-calculator. Now before I go any further, I am not affiliated with NAPLAN or Akara, and basically these are just solutions that I think are going to be useful to my students, which I've also managed to put out there on YouTube. If you are currently watching on either Twitch or YouTube, hi guys, welcome. Thank you very much for tuning in. All good. If you are not, that is fine. I'm basically recording these now because it is easy to do so, and I've had a few requests. Whoa, impromptu Sunday night live stream. Now, as you can see, I am ready to go. So let's make myself smaller and let's get on with our first questions. Now, hopefully I'm not going to make any mistakes. If I do, then obviously you can help me out along the way. But a shop sells balloons in bags of 5. For a party, 20 balloons are needed. How many bags of balloons are needed? Nice, easy question. What do I want? 20 balloons. They're sold in bags of 5, so I want 20 divided by 5, which is hopefully going to give me 4. So there we go. I'm going to colour in my little lozenge, and obviously when you're doing the NAPLAN, it's really important to make sure that you colour these things in, because it is computer read, right? They feed these through computers. If your pencil isn't dark enough, or you make mistakes or whatever else, and this was all explained to you for NAPLAN, then obviously you need to make sure that the computer can read it, otherwise you're going to get a pretty low score. Question 2. Joe measures a distance to be, what is it, 5 meters and 12 centimeters. Which of the following shows how Joe can write this measurement in meters? Right, well, we got 500 meters, which is 500 centimeters. I've got 12 centimeters, which is 512 centimeters, but it wants it in meters. How do we then do that? Well, generally speaking, we would then divide that by 100. And so I would go 1, 2, 5.12. So again, 5.12 meters would give me B as my correct answer. Whoa. Storming through this, Norman. A bag contains 15 beads that are either red or yellow. The probability of randomly removing a red bead is 20%. What is the probability of randomly removing a yellow bead? Well, in this situation, if 20% of them are going to be red, it would make sense that there's 100% in total, so I'd want to be doing here 100% minus the 20%, which is going to give me the grand total of 80%. So there we go. What would you write in here? Well, we want to write down the probability as being 80%. Not too sure how a computer's going to mark that one, but it doesn't matter. I don't care whether a computer's going to get it right or wrong. Maybe someone checks. A bag contains 15 beads that are either red or yellow. Probability of randomly removing a red bead is 20, and the probability of randomly removing a yellow bead. I'm keep reading these questions because I don't want to make a mistake. Amelia wants to find the number of people who are enrolled in either a music class or a drama class, but not both. Which shaded region in the Venn diagram represents the information? Well, we know that the both is actually this middle section here. So we are looking for a graph that firstly does not have that colored in. So that gives us this graph here or that graph there. So I'm going to actually strike through that one there, and I want to strike through that one there. Now again, if we know anything about Venn diagrams, the stuff on the outside, the color in here on the outside, is actually not including music and drama. That's not what it says. It says Amelia wants to find the number of people who are enrolled in music or drama, but not both. So I'm fairly sure in this situation, because that's the outside, that means not music and drama. It leaves me just this one here. Stormy Norman. Right, let's see, where are we now? Question number 5. Point P is translated down 4 units. What are the coordinates of the new position of point P? So it's here. I'm going to go 1, 2, 3, 4. So it's going to put me there. So let it go 1, 2, 3, 4. There we go. And if we remember, we start from the origin. We go the number of squares across first, and then the number of squares up or down. So I'm going to go 2 across and 1 down. So I'm looking for 2, -1. There we go. And I'm just going to check that I haven't made a mistake there. 6, 3 minus 2, 4. Nope. Question number 5. Storming through. No questions so far. I'm on a roll. The height in centimetre of children on the tennis team are as follows. 119, 122, 119. Select the plot that correctly displays the data. Right, okay, so I'm now going to look for the differences. I think that the differences here are quite useful. They all seem to have the 117 in them, and we do notice we have a 117, but this one here seems to show 2 at 118. Can we see any data here that has 118 in it? I don't think so. So in that situation, just by a process of elimination, It can't be that. Or in many cases, just by comparing them, it isn't the same. What have we got here? The height in centimeters. So where are now the differences with my next two? Right, well, again, I'm going to look for my difference. I've got 1 at 119 here, and I've got 2 at 119. Let's go back to my data. I have 119, and I have 119. I've got 2 at 119. That can't be right. That one there must be right. And I'm just going to do a quick check. 2 at 119. I'm just going to do some crossing off. So where's my 117? 2 at 119. 122. Yes. 124. Yes. 3 at 127, 120, 107, 127, 128. And again, that's just a small thing to do if it's going to be useful for this type of question. Right, there we go. That's question number 6. Let's slam through this for question number 7. Whew, so far, so good. And these are generally the easier questions. And if you're sitting there going, I'm already finding this hard, I don't mean that in a bad way. It's obviously they get harder and harder and harder as we go through. Beth made a ramp to replace a set of steps that were 0.5 meters high. Okay, so that's 0.5 meters high. I always write on my diagram when I got these things. The ratio of the horizontal length of the ramp to its height is 12 to 1. Oh, okay then. So I'm going to write that now. So we've got the horizontal to its height is 12 to 1. So for every 1 unit of height, I have 12 times my, what is that? For every 12 units of horizontal length, I have 1 of height, or vice versa. What is the horizontal length of the ramp? Well, basically, all I'm going to do here is say that for every one of these, I'm going to times it by 12. So 12 times 0.5 is actually 6. So I'm going to slam in there 6 meters. Again, no one's yet screaming at me that I'm making a mistake. We're doing really, really well. Tom joins a gym that has a monthly fee of $56. Oh, that's expensive. Members pay an extra $6 per session if they want to work with a gym trainer. That's not real. Not real gym trainers. I think mine charges me $90 a session. And you're going to say, you go to the gym? Don't be personal. Which expression represents Tom's monthly gym bill if he works with the trainer for X sessions? Right, well, 56 is my fixed fee. So it's got to have just the 56 on its own. And to be perfectly honest with you, that is the only one that is even vaguely close. All right. So for those of you who know your algebra, 56 is my fixed fee. He's going to pay that anyway. He's then going to pay 6 times X. So again, I'd be looking for 6X. This one here would try and trick people. That one there is rubbish. That one there is definitely not. That one there is the one that we need to pay. So effectively, I'm going to color that one in. 56 plus 6x. Here we go. Grace throws a ball from a height of 2 meters. The maximum height of the ball after it's thrown is 4 meters. The ball lands on the ground about 2 seconds after it is thrown. Which graph represents the path of Grace's ball? Which gym do I go to? Don't ask. Yeah, it's too painful to think about it. That's just because someone's asked me a question. Right, which graph represents the path? So I want one that goes to a maximum of 4 meters high. Now, again, I'm going to cross off the ones that can't be true. This one here seems to start at 2 and then go down. That can't be right. The rest of them all seem close, don't they? Because they say the maximum height of the ball, but again, it says Grace throws a ball from a height of 2 meters. Well, if we look at this one here, that seems to start at 4 meters, so that one can't be true. This one here seems to start at 0 meters. That one can't be true, so it would suggest that that one there is the only one that is actually true. Yeah, so let's just check. Does it start from 2 meters? Yes. It gets thrown up to a height of 4, comes back down and lands after 2 seconds. Ka-ching. We've got the right one there. All right, let me see. Riley is building a tabletop in the shape of a parallelogram. What is the perimeter of the tabletop? Now, perimeter, again, a lot of people get very confused. And here's a hint for you, for those of you out there who are actually watching this stuff. When we color stuff in, and you notice we've actually colored this in, or NAPLAN have colored it in, that actually tricks the brain. You get so used to seeing things that when they are colored in, you work out the area, that a lot of people will do 90 times 110 and get the wrong answer. But it doesn't want the perimeter, all right? And I always think of prison when I think about perimeter, because perimeters go around prisons. I'm just going to add all of those values together. So a quick side calculation, 110 plus 90, 110 plus 90. Lots of different ways you can do this. That adds to 200. That also adds to 200. So I'm imagining my total is going to be 400 centimeters. And that's the answer I'm going to choose. A lot of people, when they do this, go 90 plus 110 and double it. Lots and lots of ways around doing this, but we're all good. The diameter of a red blood cell is 0.0076 millimeters. Which of these shows the diameter in scientific notation? Well, for scientific notation, we have to move our decimal point between the first two non-zero numbers, or at least after the first non-zero number. So if I have 0.0076, I want to move my decimal point from here, 1, 2, 3 places. So first things first, I'm going to have 7.6. Scientific notation, if you remember, has that times 10. All I'm going to do now is work out how many decimal places it jumped. How many times did it jump? 1, 2, 3. So it's got to be a 3 there. But is it plus or minus? Well, because it's a really small number, all right, it's got to be a minus. So 7.6 times 10 to the minus 3. Which one is that one? 7.6 times 10 to the minus 3. That would give me my first value there. Question 12. Jane and David had identical chocolate bars. David ate 7/10 of his chocolate bar. Jane ate more of her chocolate bar than David. What fraction of her chocolate bar could Jane have eaten? OMG. Right, well, we've got 7ths, 9ths, and 10ths. How are we going to do this one? Well, let's turn all of them into... I'm trying to find my lowest common denominator of 8s. Right, this is going to stump me. Let me think where we come up with 7/8 of his chocolate bar. 6 7ths, 7th, 9ths. 8 9ths or 8 10ths. So let's see where we go this one. 13 I can already do in my head. 12. Right, Jane ate more of a chocolate bar than David. That's good to know. What fraction of a chocolate bar could Jane have eaten? All right, let's turn this into, right, let's do this the hard way. Let's 8 times 7. So what I'm going to do is say 7/8 and 6/7. So let's do 8 times 7. 7, 7, 4, 9, 56. So let's make that 56 on the bottom. Times that by 8. 8 6s are 48. Right, times that by 7. So 7/8. Times that by 7 gives me 56. And times the top by 7 gives me 49. So in which situation? Jane's got to eat more. It can't be 6 7ths. Let's go to 7 9ths. Right, so what I'm now going to do is I'm going to do 9 times 8. 9 times 8 is 72. So 7 times 8 gives me 49, 56. And let's do 7 on 8. And let's turn those into 70 seconds by timesing the top by 9. 9, 63 out of 72. Nope, still Jane has eaten less. Okay, so that's no good. We've got 8 9ths and 7 8ths. So we've already done on 72 here. So let me see what I've got there. Times the 8 8s are 64. And then we had 7 8s was 63. So before I go any further, I'm going to go 8 9ths as my right answer. But I'm actually just going to check, and I'm going to turn this into 80ths. Again, if you want to know why I'm doing 80ths, 10 times that. I'm just trying to get them into common denominators, because that's the best way to compare fractions, is actually using common denominators. So let me see. So I've times the top by 8, so let's make that 64. And then I've got 7 8ths, and I'm going to make that out of 80s. So times that by 10 gives me 70. And in which case David would still have eaten more. So again, 8 10ths can't be the one. That question took a long time to work out. If you've got a better way of doing it and you're watching it on YouTube, let me know. Always good to know different ways. Monty and Tara buy pencils for school. I don't know why. Tara buys 2 times the number of pencils Monty buys, plus an additional 4 pencils. Let M be the number of pencils that Monty buys, which expression buys the number of pencils Tara buys. So Tara buys 2 times. So if Monty has M, Tara buys 2 times as many, plus an additional 4. All right, so that's a bit tricky there, isn't it? Have they got one there that looks like that? Nope. Oh, yes, they do, but they're just writing it in a different way. So if we look at this one here, right, that's definitely got plus 4. That doesn't have a plus 4 in it. That doesn't have a plus 4 in it. So by trial and error, or even just by looking at it, you can probably see it's part A. They're just trying to trick us here by putting the 2 and the M in brackets as 2 times M. Not wrong mathematically, but certainly there to try and trick us. A fair $1 coin and a fair $2 coin are tossed at the same time. What is the probability that both coins will show tails? All right, I don't really care whether it's a $1 coin or a $2 coin, because if we look at the outcomes, right, if it's the probability that both coins will show tails, we can have a head followed by a head followed by a tail followed by a head, or a tail followed by a tail. So we're looking for this one here. And the individual probabilities of each of those is it's a half for a tail on the first one and a half for a tail on the second one. And so I'm pretty certain it's 1/4 for that one there. Myra draws a scale map of Australia on a coordinate grid. Timey kangaroo down sport. That's my best Australian accent. Yeah, I live over here. Anyway, Myra draws a scale map of Australia on a coordinate grid. I swear I've done this paper. I don't know why someone's asked me, can I go through this one? Because I'm 98% sure I've already done this one. But anyway, she knows what the actual distance between Perth and Sydney is 3294 kilometres. Which scale should Myra use for her map? Okay, so what I'm now doing is for scales, we're trying to say, well, how many squares have I covered to get from Perth to Sydney? So they've got 1, 2, 3, 4, 5, 6, 7, let's say 8 squares. So 8 squares on my map stands for, how far did they say? 3294. So what would one square give me? Well, to be able to do that, I'd have to divide each side by 8. So 3294 divided by 8, 8, 16, 24, 32, that's 4. 8 into 9 go twice, remainder once. 8 into 14 go 8's about once. So we are looking for, roughly speaking, any number on our answer that looks to be around 400 kilometers. And so in which case I am going to put that one there as 400. All right. This triangle is reflected across the dotted line and then rotated 90 degrees clockwise. Whew, what is the resulting image? Right, well, if I reflect it, let me see if I can actually draw this. If I reflect it, I'm going to get something like this. You can draw a triangle for me? There we go. And then I don't know if it actually is going to let me rotate it. Will you rotate around? Probably not. Oh, no, it'll make me grow longer. If I then rotate that 90 degrees clockwise, which is that way, I am pretty sure my triangle is going to look something like that, which means that the only answer I can get would be this one here. Whew, thank you very much. Right, question 17. The mean age of employees at a company is 40. That means I've taken all the ages of the people, added them together, and I have divided by how many people there are, and I got 40. The median age of employees at the same company is 35, which means the middle person is 35 years. A new employee is hired who is 55 years old. Which of these is possible? The mean age stays the same, and the median age increases. Nope, not at all. When I add someone in, the mean age is going to change. The mean age stays the same and the median age decreases. Nope, I can't have the median age decrease, because if I imagine I've got 35 as the middle and I'm adding 55 on, it's going to make my median move that way, so it's going to be bigger. The mean age decreases and the median age increases. Nope, the mean age increases and the median age stays the same. Hold on, I don't like any of those. Right, the median age is definitely going to increase. The mean age stays the same. Which of these is possible? The mean age stays the same. All right, maybe, I suppose. The median age is definitely going to increase. The mean age stays the same, the median age decreases. That can't be right, so I'm going to cross that one off. The mean age decreases. Highly unlikely if I've got someone who is older. So the mean age increases and the median age stays the same. Well, okay, by a process of elimination, guys, I'm going to say it has to be A. I mean, theoretically speaking, lots of people could be 55 years of age, in which case the mean age maybe wouldn't stay the same, because we might have a lot of 55-year-olds there. But again, these are harder. These are more mind tricks than maths. Vicky and Anya are saving money for a holiday. Vicky has $300 and plans to save 20 each week. Anya has $250 and plans to save 30 each week. After how many weeks will Vicky and Anya have the same amount? All right, I have definitely done this paper. So whoever out there has asked me to do this paper, I swear to you I've already done it. But anyway, 300 and 250. Right, so we're going to do 320. Let's rub that out. 320, 340, 360, 380, 400. All right, so what do we got next week? Vicky has, excuse me, Anya has 250, adds 30 each week, so 280, 310, 340. Okay, so after how many weeks will Vicky and Anya have saved the same amount of money. All right, so 340, 370, and 400. And I think, again, the trick to this question here is I looked at that and said, well, they have the same money at 340, but it's not the same week. All right, that's what they started with. That was week 1, week 2, week 3, week 4. It seems to be week 5 that they have the same amount of money. So I'm going to put 5 weeks there. Select the statement that is true about triangle A, B, and C. Triangle ABC is scalene. All right, so first things first, if we notice anything about a triangle, first things first, it is right angle. So I'm going to write a right angle in there. Angles in a triangle add up to 180 degrees. That must also then be 45 degrees. All right, so 2 angles are the same, which would suggest that these 2 sides here are exactly the same length. So let's see, triangle ABC is a scalene. Scalene means what? All the sides are different lengths? No, ABC is isosceles. That's looking likely. Triangle ABC is equilateral. Nope, for it to be equilateral, all of the angles would have to be the same, minus 60 degrees. Triangle ABC is obtuse. Certainly not. It is right angled. So again, in that situation, there can only be one answer. And what did I say it was? It's going to be isosceles. He says mispronouncing it because I can. Question 20. How many questions are in this test? A group of 105 people were asked if they were left-handed or right-handed. The table shows the results. A man was selected at random. What is the probability that he is left-handed? A man is chosen at. So what have we got here? We've got, there are 50 men. And what is probably he's left-handed? We've got 15 out of 50. So 15 out of 50. I want to turn that into a percentage. So the best thing I can do is make that out of 100. And so times that by 2 means I've got to times that by 2, which gives me 30 over 100, which as a decimal is 0.30. So that was testing your probability, your fractions, and whatever else you got there. So let's say 20 is 0.3. Which of the following is always equal to x minus y? Now, they're trying to trick you there. It's just a trick of algebra. So what I can actually do is I can move things around. So I can actually say that that becomes minus y plus x, okay? So long as I keep that minus sign by the y and the positive sign by the x, do I have a minus y plus x? I should cocoa. And so that one there would have to be my correct answer. Question 22. A plan of the lawn in Pat's backyard is shown. Pat wants to fertilize the lawn in her backyard and needs to know the total area. What is the total area? We can do that nice and easily again. Right, so I've got 2 shapes here. This is a composite shape. I have a rectangle. Sorry, try that one again. A square, and I have a triangle. So the area of my square is going to be base times height. He says trying to bring his hands on screen and not doing it. So that's going to be 3 times 3, which is 9 square meters. The area of my triangle is a half base times height, which is a half. Now the base is basically this bit here. Okay, so that's 3 meters. So that's going to be 3 times, and again the height would be this bit here, which happens to be my 2 meters. So 3 times 2 is 6. Half of that is 3 meters squared, and then we would need to add those 2 together. 9, 10, 11, 12 to give me 12 meters squared. Question 23. Am I almost at the end of this paper? Sure, it's got 30 questions. Glenn has 6 cups of sugar. Sugar's not good for you, Glenn. Back off the sugar, mate. A biscuit recipe uses 3/4 of a cup of sugar for each batch. What is the greatest number of batches Glenn can make? Well, I'm basically trying to do 6 divided by 3/4, right? We're trying to work out how many 3/4 go into 6. Well, I can't do 6 divided by 3/4, but I can do 6 times 4 on 3. Remember, keep, change, flip. All right, well, can't multiply that at the moment, but I can if I make it 6 on 1. 3's, I'm going to do a bit of cross-cancelling. 3's going to there once. 3's going to there twice. And so now I can say that 2 times 4 is 8, divided by 1 gives me 8. My correct answer is 8. And again, with that question there, it was testing, A, did you know it was a division question? Did you know how to do keep, change, flip? Could you do some cross-cancelling? Again, I only did cross-cancelling because it was easier. If you did 6 times 4 on 1 times 3, for example, 6 4s are 6, 12, 18, 24. Divided by 3, and again, if you do 24 divided by 3, you get 8. The same answer. Paul is playing a guess my number game. Paul, get out there, get a life. He gives these clues about his number. Paul really has no life. My number is a square number. My number is divisible by 2 and 9. My number has 2 digits. Great. All right, so first thing I'm going to do is write down my square numbers, which is 1, 4, 9, 16, 25, 36, 49, 64, what's that, 81 and 100. All right, I don't need to go any further than that because the first thing it says is my number has 2 digits. So because it has 2 digits, I'm going to get rid of all the numbers that don't have 2 digits. There we go. The number is divisible by 2 and 9. Oh, I've written down my square numbers. So let's get rid of that. I've done that as well. So now I've got to have my numbers is divisible by 2 and 9. So firstly, it's got to be even because no other even numbers can only be divisible by 2. So that's no good now. That's no good. And that's no good. Whew, we're getting there. And so we're looking for something now that's in the 9 times table. 9, 18, 27, 36, 45, 54, 63. There we go. The number would have to be 36. Again, when you're going through these questions, this is just my way of doing it, just to give you an indication. Leslie has read 5/8 of a 256-page book. Keep going, Leslie. Love the reading. Which decimal shows how much of the book Leslie has read? Well, again, lots of ways of doing this. When I was at school, we were taught to actually learn all of the most common decimal numbers. And I remembered that 1/8 was 0.125. So I can times that by 5 if I wanted to. 5 5s are 25. 2 times 5 is 10, plus the 2 gives me 12. Anyone in Australia now is going, why have you put the 1 and 2 under the line? Because that's what's right. 0 times, sorry, what did I have? Total 25, 2 times 1 times 5 is 5, plus 1 is 6. And there we go. So 0.625 is in fact the right answer. And in fact, you could have done it a different way. I could have done what it was 5 divided by 8. Obviously, I'm going to put some zeros in there. Well, 8s don't go into 5, so I put the 5 there. 8s go into 50, 8, 16, 24, what is it, 8, 16, 24, 32, 40, 48. 48, so that's what, 6 times, the remainder 2, 8, 16 goes into the 2, remainder 4, 8's going to 45, and you could have got that way as well. All right, Jason wants to multiply 35 by 62. Which of these expressions will give Jason the correct answer? Again, this is one of the tricks that I now teach my kids at school. 35 can be 30 and 5, 62 can be 60 and 2, and so that's the same as 30 plus 5 times by 60 plus 2. Right, 30 times 5. Is that giving me one of the suggestions? Nope, that's not very nice, is it? 30 times 60 plus 5 times 2. No. 30 times 2 plus 60 times 5. And again, if we look at this grid here, the reason this is a no is if I do 30 times 60, that's going to give me that box there. If I do 5 times 2, that's going to give me that box there. What it's not going to give me is this bit here and this bit here. So it's only going to give me part of the sum. So that can't be right. All right, so I'm going to say no to that one. 30 times 2, if I do that again here, 30 times 2 is going to give me that one there. And 60 times 5 is going to give me that one there. Nope. All right, I have a feeling I'm going to end up backtracking on this. 30 times 62 plus 5 times 62. 30 times 62 plus 5 times 62. Actually, yeah, I think, again, that's going to be the answer. We'll come back to that. 30 times 60 is going to give me this box here. He says not doing highlighter. 30 times 60 there, yep. 30 times 2 gives me that box there. 60 times 5 gives me that, but it won't give me this one here. So it can't be that one. It's got to be this one here. And again, because they've tried to be tricky, they've split 30 into 30 and 5, but they've left the 62. So in which case we've got 30 times 62 plus 5 times 62. It's got to be that one there. Again, these are just tricky for the sake of being tricky. Holly is saving to buy her first car. Go, Holly. She creates a table to keep track of her. Don't buy the car. You've got to think about the rego. You've got to think about the petrol, the insurance. It's too much. Holly is saving to buy her first car. Sorry, I've already read that. She created a table to keep track of her savings. Complete the rule for the linear relationship between the amount of money in Holly's savings account. So in this situation here, what they're asking me to find is the gradient. Because again, if you have been doing this, you know that equations of lines are given by y equals mx plus c. All right, so what we're missing here is, if you notice, we've got the y, we've got the x and the number, the y, the x and the number. So we're trying to find this, which is the gradient. And how do we do the gradient? Well, we look at the difference between these two values and the difference between those two values, and we divide them. Or we do rise divided by run. So my rise in this situation would be 430 minus 310. And the reason I'm doing that is these here are my rise values. So I'd be doing 430 minus 310, and I'm going to divide that by 5 minus 2, right? 430 minus 310 is going to give me 120. 5 minus 2 is going to give me 3. Divide those is going to give me 40. So in that situation, 40x plus 230. And if I wanted to check that that was right, if I take my x value of 10, I would do 40 times 10, which would give me 400, plus the 230 gives me 630. I know I have to be right. Michelle bought a pair of sunglasses, itchy head, which cost $19.50 before the GST was added. How much Michelle's sunglasses cost after adding 10% GST? So the first thing I'm going to do is I'm going to add on 10% of $19.50, and the best way to do that is basically divide by 10, which is going to give me $1.95. So there's my GST, and so then I would be doing $19.50 plus $1.95. That's 5, 14, carry the 1, 10, 11, carry the 1, gives me $21.45. And again, if you're wondering why I'm writing my ones down there, because it's right. I don't know why you keep writing the ones all about tough. It's a bit strange. Harper has a tablecloth with an area of 3 square centimeters. What is the area of his tablecloth? Sorry, 3 square meters. What is his area of his tablecloth in square centimeters? Again, if I have centimeters to, what is it? Let's try that one again. If I have meters to centimeters, I times by 100. Yeah, because there's 100 centimeters in a meters. If I want to go from meters squared to centimeters squared, which is what I'm doing, then I times by 100 squared. That's 100 times 100. So in this situation, I'm going to do 3 times 100 times 100. So that's going to give me 3 and 4 zeros, and that would have to give me that one there. Now again, a lot of people get tricked here because they think all they need to do is times by 100, because from meters to centimeters, nah, you've actually got to go the other way around. Question 30, I think this is the last one. Sam rents a truck from a hire company. The cost to rent the truck is directly proportional to the number of kilometers driven. The rental cost to drive 200 kilometers is $87.50. What is the rental cost to drive 80 kilometers? Right, so it's directly proportional. So we know that, what is it? So the cost to rent, the cost is equal to some constant times my distance. So we know here the cost was $87.50 is equal to some sort of constant times my distance of 200. So I'm going to do 87.50 divided by 200. They're not very nice here, are they? Is there another way to do this question? Yes, actually there probably is, because that seems a bit stupid. Let's rub out that working there. Right? So we know that we've got 200 kilometers is equal to $87.50. I'm going to divide this both sides by 10. I'm going to show you why. So 20 kilometers is $8.75. All right, so by dividing each side by 10, because it's proportional, I can do that. It gives me 20. And then to get to 80 kilometers, I would just times by 4. So in that situation, I'm going to times by 4 both sides. So $8.75 times by 4 gives me 20 there. 7 fours are 28. Add the 2 gives me 30. 8 fours are 8, 16, 24, 32. Add the 3 gives me $35. And so I'm going to say $35 there. And I'm fairly sure. Oh no, there's more. Oh my goodness. How many questions are on this calculator paper? Oh, non-calculator paper. All right, question 31. Mona walks. God, I'm getting tired now. Mona can walk from home to school following the roads, or she can cut across a vacant block. Don't do it, Mona. That's quite dangerous, really, cutting across vacant blocks. Someone owns that block. Anyway, as shown in the diagram below, along the road she walks 60 meters and 800 meters south. How many meters less does she walk going along the vacant block? Right, because they want less. The first thing is a bit of a trick. If she goes this way, she is going to walk how many kilometers? So she's going to walk 600 plus 800, which gives me 1400. I said kilometers, probably not. Long way home. All right, meters. That's almost back from here to the UK, I think. Now, again, this is a bit of a trick. It's a right angle triangle. And for those of you who've done Pythagoras theorem, you know we have a special triangle called the 3, 4, 5 triangle, which, when we double, becomes the 6, 8, 10 triangle. Oh, hold on a moment. 6, 8, 10? That seems familiar, don't you think? Well, if I times each of those by 100, I get 600, 800, and 1,000. So if she goes directly, she's going to do 1,000 meters. So the difference, if we take away the 1,000 meters, gives me 400 meters. So how many less does she walk by going across a Benton block? It's 400 meters. This table shows, oh, there we go, that's nice. It actually says end of test. This table shows the receiving areas of 2 large radio telescopes. What is the ratio of the receiving area of the ASKPA telescope to the receiving area of the SKA telescope? All right, here we go again. So first things first, it's a bit of a trick. They're trying to trick you because we've got different units. We've got square kilometers and we've got square meters. So I'm going to change my square kilometers into square meters. Right, so kilometers into meters is how many? So if I go from kilometers, I'm going to times by 1,000. So kilometers squared into meters squared, I'm going to times by 1,000 squared. So that's going to become 1 and 6 zeros. All right, so the SKA is going to give me 1 million square meters, right? So what is the ratio of the receiving area of the ASKP? So we have to do that one first because the order is given to me. So I've got 4,000 to 1 million. Right, so what we can do to each side is start dividing. So 1, 2, 3 of those zeros go. 1, 2, 3 of those zeros goes. That gives me 4, 2, 1, 2, 0, 1, 2, 3 zeros there because we've got 3 off of either side. Again, we can cancel down by 2. It gives me 2 to 500, and I can cancel again to 1 to 250. And there we go. That is my final answer. Yes! Finished the question finally. Thank you very much for watching, he says. Let me just try and get myself back up to a bit louder. Hopefully this has been useful. All right, I'll try and pump out another video in just a moment for, I don't know, the other one that someone asked me to do. And yeah, and then go back to recording the VCE stuff. If you can, subscribe to my YouTube channel. Thank you very much for watching. I'll see you again. Bye-bye.